So on this question, there are a few different approaches, and we'll go ahead and walk through each of the, in my opinion, three primary approaches. The first one is my preferred approach, since you know I love the graphing calculator programs that we've created. So we would go over to our program Solve Systems because we do have a system of linear equations. So let's go down to that program, which is program number 4. And when you go in, notice it shows you that each equation needs to be in standard form, where you have x's, y's equal to the constant. So this bottom equation is already in standard form. We're good to go there. For the top equation, we just have to make one little baby step in order to have it in standard form. So we're going to bring that x over by subtracting it to the other side. And that makes it so we have negative x plus y equals negative 2. And then we still have the same bottom equation. I'm just going to rewrite it for visual purposes here. And then we'll go ahead and type in all these coefficients. So notice we have negative 1 in front of the x. And it's really important that you use this negative key down here instead of the minus key. Otherwise, you'll get an error. So negative 1, enter. Positive 1 for the coefficient in front of y. Since there's nothing written, we assume it's positive 1. And then negative 2 here for the constant, same thing, make sure you use the negative key. And then we'll go ahead and type in these coefficients of 3, 5, and 30. So we get the point of intersection, which is 5, 3. And in this case, they just want the x coordinate. So we know the correct answer is going to be B. So pretty nice and easy there. The second approach would be using Desmos, which we have in our software here in the upper right corner where it says calculator. And you also have it, of course, in the same spot in the actual Blue Book, the platform for the digital SAT. So I'll go ahead here and we'll type in these two equations. Now, for this top equation, since it's y equals, you could just type in the right side of x minus 2. You don't have to worry about putting y equals, although you can. However, for this bottom equation, we're going to have to type in everything since it's not just a y equals. So we'll go to equation 2. We'll type in 3x plus 5y equals 30. Now, I'm a big fan of just using my actual keyboard. However, you're definitely welcome to use the keyboard that they provide you. I'm just a little bit more comfortable with my own. And then we're going to go ahead and look at the point of intersection. So I'm going to go here, and we see that it's 5, 3. Again, they just want the x coordinate, so it's 5. Arguably, this is, just as fast, if not maybe even a little bit faster than using the graphing calculator program. So both are really great approaches. And then the third approach, in case you're curious how to do it by hand, which is good to know for your actual math class, if you go to the back side of page 33, which is side 2 of our math reference documents, you'll see that we have substitution versus elimination as the two primary algebraic approaches for solving a system of equations. Now notice substitution is really convenient if one of the two equations is already isolating a variable. So in this case, you have y equals. Whereas elimination is convenient when they're both already in standard form, and especially if none of the coefficients is 1 or negative 1. Because if a coefficient isn't 1 or negative 1, imagine if you try to isolate one of these variables, you're going to get fractions all over the place, which can be really difficult to then do substitution with. So elimination makes sense in that case. Well, let's look at our setup here. Let's get rid of the calculator portion. And notice we do have the top equation is already isolated for y. So in that case, I would go ahead and do substitution. So since y equals x minus 2, in this equation, in place of y, I'm going to go ahead and put x minus 2. And then we'll go ahead and distribute here. So we get 3x plus 5x. Make sure you do 5 times negative 2 and get negative 10. Combine like terms. We'll go ahead and add the 10 to the other side. We get 40. Divide by 8. And you still get the same answer of 5, making the correct answer B. If they did ask you for the y coordinate, very easily, you would just plug in the 5 back into either equation. In this case, the top one is much easier because y is already isolated. So 5 minus 2 equals 3, and then you'd be good to go from there. But again, those are the three approaches. My preferred one is definitely either the graphing calculator program or Desmos.